In this video, we're going to be looking at a concept on why chemistry as a subject it matters, and this here includes the following based on what are we going to achieve in this video. One is that we need to define what chemistry is, and using the definition there are three things that we're going to break down in the definition of chemistry, and this includes the following. First, in terms of the definition of chemistry, we know that chemistry dives really deep into evaluating the properties and what? Also looking at the composition of a specific type of term, which is known as what? Which is known as matter. And you might be wondering, yes, I've heard of this particular term here, and indeed, matter here in terms of the definition is what? Anything that has mass or and inertial, and this here based on the definition of mass. When we look at it relative to we humans, we evaluate mass as what? Weight. And when we look at weight, we know that we are accessing this property of mass when we connect it to the acceleration due to gravity of you or any object that is on Earth's surface or any planetary body if you are placing that object on. And inertial, of course, is any object that is stationary, that is not moving. So that is something to keep in mind. Now, not only are we using this particular segment for matter, but also we need to consider the space that an object occupies. For example, you might be wondering, does a gas have space? Yes, they do not only have mass, but also they take up space. So yes, indeed, gas is considered to be matter. However, how about sunlight? Of course, based on this statement, you will consider that sunlight is not matter, even though we talk about light being a particle versus that of the wave duality. That is one of those topics that we're roaming around doing the introductory phases to quantum mechanics. But for sunlight, we consider it to be what? Energy related, and we'll talk about this in details in future videos. And so, looking at this here, we are going to look at the next step. What are the things to expect when it comes to the composition? And next segment here, we're going to look at what are the things that we need to expect for the properties. And this here includes what? The following. Now, first, looking at matter in terms of the composition, there are going to be two things that we're going to connect in here based on composition when we are given a particular sample, and this includes the following. One thing that we need to consider for composition is known as the components that are in the sample or that make the sample, and the other part that we need to consider for the composition is known as the proportion of the components in that particular sample. So let's take, for example, for a sample in here, water, we know that the composition of water has the following elements to be hydrogen to that of oxygen. And when we look at the components leading to the proportion of these particular items that make up the sample, we recognize that for hydrogen in water, it is around 11.19%, and for oxygen, it is around 88.81%. by what? Mass for proportion. And let's look at another sample that has the same component but not water. We look at another one which is known as hydrogen peroxide, and when we look at this in details based on the component, we do have hydrogen. We're going to write it as the element symbol and that of oxygen. And when we move on to the proportion, we recognize that for hydrogen, instead of it to be 11.19, we have it to be around 5.93%, and for oxygen here we have it to be around 94.07% in terms of what? The mass. So it's incredible to see how two samples that have the same component do have different proportion when it comes to the mass. Now the next part here is how does matter relates to another particular definition, and this here is how we need to be able to distinguish matter based on what? The properties. And these properties comes in two forms. One is how are we going to differentiate matter based on the physical look, and physical look can include the following: either one, looking at the color, or looking at how malleable, which means that when you heat it, how is it able to compress, or brittle in this case here when we look at it. Also we look at ductile in terms of how you can make it into some kind of a wire looking form, and many more things, like for example, is it a good conductor of heat and electricity. All those are things that we need to consider when it comes to the physical look of a particular matter in terms of differentiating it. Now the other form here we're going to look at is known as how can we differentiate properties chemically, and this here includes the following: when we are looking at chemical reactions that may occur, and those reactions involves when one or more items are interacting together to make something new. Now looking at these two here, we're going to look at it now based on what? How the changes occur. Now in terms of the changes, we need to consider something here, which is the composition, and thus the composition of the individual components. Do they change for physical? Not really, they don't change at all. However, for that of the chemical part, they do change. Yes, they change. And so what are examples of this type of thing when it comes to physical that doesn't change in terms of the composition of the different items? An example would be when you have liquid water and it is transformed to that of ice. We see at the particular atomic level that you're still dealing with H2O. It doesn't change, either going in this direction or in that direction. You still have the same proportion of hydrogen, which is going to be around 11.19%, and that of oxygen to be around 88.81% by mass proportion for this following component in this particular sample here of liquid water to ice. However, when it comes to looking at the chemical form, for an example which states that yes, the composition changes, we're going to look at an example like, for example, we have here CH4 reacting with what? 2 molecules of oxygen, and what we notice is that this process, which is known as combustion reaction, will lead to the formation of a new composition, which is what? Carbon dioxide and 2 molecules or 2 compounds of water. And this here shows how this here is different from this here is different from that, different composition or proportion of what we have here to what we have here. Yeah, but that is the idea when we have a chemical process happening that allows us to differentiate one matter from another, or when they are interacting with each other. Another one can be, for example, we have zinc and this here is going to be reacting with hydrochloric acid, 2 molecules or 2 moles of hydrochloric acid. This here, when they interact, they form a particular product that is zinc 2 chloride, and produces or releases hydrogen gas. The same idea, the composition changes from one side to the product, the other side here. So that is something to keep in mind here. Now, other honorable mentions is the following. How do we connect the physical and chemical in terms of matter? So let's say, for example, we have these following items here. We have zinc, we have gold, and we have sodium. Now, these here are different elements, and what they share in here is what? The physical state. The physical state or properties that they share includes: 1, they are malleable, and most importantly here, they are conductors, good conductors of heat and electricity. Now, this here now changes when it comes to when they are going to be subjected to a particular compound, and the outcomes here will make a huge impact as to how they are used in the real world. Like, for example, here zinc, when it interacts with water, what we notice is that it doesn't react with water, and that is why zinc is a great example of when it is used for roofing or any materials used for roofing. Next is, how about gold? Gold, we know when it reacts with, it doesn't really react with anything including water, so which means that, 1, not only it has 0 rusting abilities, but also importantly, this here is a valuable resource here which we use for various particular purchasing of items, because this kind of item here, which is gold, appreciates over time. And finally here is that of sodium. Does it react with water? Yes, absolutely, it reacts with water, and once it reacts with water, it's going to form a particular base and it's going to release hydrogen gas. So that is an application of when we are looking at matter based on the properties, when we are connecting physical states and chemical states, and how changes are applied to the chemical phase, but not really at the physical state when it comes to the composition. So overall, I hope you found this really informative regarding why chemistry matters, where we looked at the following keywords here, and these keywords, like for example, matter in chemistry, which focuses on not only the properties, they're also looking at the composition, and how for the composition we consider not only the components but also the proportion. However, on the other side, for properties, we can look at not only physical states but also chemical states that are also showing changes in favor of chemical based on the composition, however not the same for physical state. And while matter here, we looked at how it depends not only on the mass but also depends on the space that a particular object occupies. Hope you found this really informative. Hit the comment down below, let me know your thought about this, or hear your thought about this, but that way we can talk to you soon. Stay smart as always and believe in yourselves.